Welcome back to the deep dive. Let's just jump right in with a number that, honestly should make you pause. $50 billion.
Yeah, 50 billion. That's the estimated annual cost globally for manufacturers dealing with unplanned downtime.
It's staggering. Basically the price the world pays because we wait for machines to break down.
Exactly. The cost of surprise failures.
Right. So imagine you didn't have to wait. What if you could, I don't know, see it coming? Eliminate that cost.
Well, that's what we're digging into today.
Yep. We're unpacking sources that show how AI is starting to do pretty much exactly that. We're going to walk you through 4 key ways it's transforming factories, saving companies millions, and, cutting that downtime sometimes by half.
And there's a twist towards the end.
Oh, yeah. Stick around for that. We've got a surprising insight, a hidden bonus, really about how all this connectivity is actually playing into cybersecurity. A bit counterintuitive.
Definitely. By the time we finish this deep dive, you'll genuinely know something about the future factory floor that, well, 99% of people probably don't.
So the mission today.
We're synthesizing how AI is fundamentally rewriting the rules of global production. It's the engine behind what people call the fourth industrial revolution, or Industry 4.0.
And the numbers back it up. That global industrial AI market. Expected to hit, what, over $115 billion by 2030?
$153.9 billion, yeah. The growth is just explosive. We're looking at the core drivers behind that massive shift.
And it really starts with tackling an old, painful problem, that traditional way of doing things, reactive maintenance.
The if it ain't broke, don't fix it approach, which sounds fine until it breaks.
Exactly, because the sources are clear. Emergency repairs cost 3 to 5 times more than just planning the work ahead of time. It's just not sustainable.
Which brings us perfectly to our first big insight, predictive maintenance.
Mm.
This is where AI acts like that crystal ball you mentioned.
Okay, so how does it work? Is it super complex?
It's sophisticated, but the concept is straightforward. AI analyzes streams of real-time data from sensors on the machinery, vibration, temperature, pressure, or even acoustic signals.
Sound, like it listens to the machine.
Pretty much, yeah. It uses machine learning, think regression, anomaly detection, neural networks to learn the unique signature of a machine running perfectly. Its healthy fingerprint, if you will.
So if that fingerprint changes even slightly.
Bam. The AI flags it as an anomaly. It learns what normal looks like, so anything outside that pattern gets attention. And the key thing, it can predict failures often 3 to 6 months before they happen.
3 to 6 months, that's incredible lead time.
It's huge. We saw data from a Fortune 500 manufacturer. They cut unplanned downtime by 45%, saved them $2.8 million a year.
Wow, $2.8 million annually. That's not small change.
Not at all. And generally, the sources show this tech delivers around a 20 to 40% cut in maintenance costs overall.
And you see big names adopting this, right? Like Rolls-Royce?
Absolutely.
Yep.
Rolls-Royce uses digital twin platforms for their jet engines, essentially virtual copies. They simulate stresses, predict wear, and they've seen about a 40% drop in reactive maintenance needs.
So they model the failure digitally before it ever risks happening in the real world.
Precisely. And it scales. There's an anecdote about a steel plant they avoided losing a massive transformer, like a $3 million loss, because the AI caught these subtle degradation patterns way in advance.
Okay, these results are compelling. Predictive maintenance seems like a game changer. But, if everyone like Rolls-Royce and BMW starts doing it, doesn't it just become the new standard, the expensive ticket just to play? Where's the next advantage?
That's a really sharp point.
Yeah.
The next level isn't just predicting failure, it's preventing imperfection from the get-go. And that leads right into our second core insight, computer vision for quality control.
The eyes that never get tired.
Exactly. Human inspectors are great, but they face limitations, right? Fatigue sets in, subjectivity plays a role, lighting conditions change. Computer vision offers 247 consistency and, frankly, superhuman precision.
How superhuman are we talking? What can it actually see?
We're talking deep learning algorithms, spotting defects in real time that are often invisible to our eyes. Think microcracks in metal components, subtle variations in plasma during semiconductor etching, even making sure the right barcode is perfectly placed.
So way beyond just checking if a screw is missing.
Oh, miles beyond. BMW developed their own platform, AIQX, which automates a lot of these quality checks and gives immediate feedback right on the line.
Okay, that's impressive. Any other standout examples?
Yes, this one's fascinating. Vitracaro, a ceramics maker in China, put AI vision systems inside their kilns.
Inside the kilns. Where humans obviously can't go.
Exactly. Tracking quality during the firing process itself, the result. They cut their scrap rates wasted products by an incredible 68%.
68% less waste. That changes the entire cost structure of making something.
Fundamentally. And Agilent in Germany, they saw a 49% drop in defect rates in just 4 months using AI vision.
Wow. Okay, so this really underlines that shift you mentioned. It's moving from catching bad parts at the end to preventing them from being made badly in the first place. Proactive, not reactive quality.
Precisely. And that proactive approach gets supercharged when you connect everything together. Which takes us to core insight 3, smart factory automation, the fully connected ecosystem.
Right. Moving beyond just one machine or one process to the whole factory floor humming along.
And Samsung's smart factory in Korea is maybe the poster child for this right now. Reports show over 70% of their processes are automated.
70%. How do they manage all that?
They have the system called Predict Eye. It integrates everything, IoT sensors, CCTV cameras, even thermal imaging, to get a complete picture of operations in real time.
And the payoff.
It's significant. A reported 25% boost in production capacity, and they cut defective product rates in half, a 50% reduction.
That's huge. And it's not just about robots bolting things together, is it?
No, it goes way beyond traditional robotics.
Yeah.
AI is optimizing inventory flow, coordinating fleets of AGVs. Those are autonomous guided vehicles like smart carts, moving materials around and allowing for much more adaptive manufacturing lines that can change based on demand.
Tesla does something interesting here too, right? With digital twins.
Yeah, they create a digital twin for basically every car they build. Then they collect data from that car throughout its life out in the real world.
And feed that back into design and manufacturing.
Exactly. It creates this continuous improvement loop. Real-world performance data, constantly optimizing future designs and how they build them.
Okay, so we have these incredibly automated factories. This naturally leads to the question, what happens to the human workers? Are they just out of a job?
That's the million-dollar question, isn't it? And it's the payoff to that curiosity loop we set up earlier.
Right. Does automation mean elimination?
Not necessarily. It really seems to mean transformation. The Samsung example is telling. Their system actually elevates workers into roles they call skilled craftsmen.
Skilled craftsmen. Doing what?
They oversee the complex automated systems, manage the sophisticated quality control, and handle the more intricate assembly or problem-solving tasks that still need human ingenuity. They shift from repetitive manual labor to higher-level cognitive work.
So potentially higher job satisfaction, more engaging work.
Often, yes. And higher overall productivity for the factory. It becomes a human-machine partnership, not just replacement.
Okay, that's a crucial point. So we've predicted failures, perfected quality, automated the factory floor, empowered the workers, but none of that works if the parts don't show up right.
Exactly. A smart factory is only as good as its supply chain. Which brings us to the deeper value layer, supply chain optimization on a global scale.
Managing this must be incredibly complex. Millions of parts, thousands of suppliers, demand swinging wildly.
It's a massive data challenge. But AI thrives on that complexity. It can turn that chaos into a competitive advantage, speed, and efficiency.
Okay, give me an example. How does this work in practice?
Look at Microsoft. They manage a huge global logistics network. They used AI to automate planning for fulfillment across dozens of distribution centers. The result, planning time dropped from 4 days down to just 30 minutes.
4 days to 30 minutes. Seriously?
Seriously. And accuracy went up by 24% at the same time.
Wow. Okay, who else is doing this well?
Nike is another great case. Their AI system manages production capacity across something like 500-plus factories worldwide, and it adjusts distribution daily for over 120,000 different products, SKUs.
120,000 product types, daily adjustments.
Yeah, and by doing this, they managed to slash their lead times by 50% while keeping fulfillment almost perfect.
That agility is key. What about retail, dealing with constant store-level changes?
Target is a strong example there. Their AI monitors over 1,900 stores, crunching, get this, 4.5 million data points every hour.
4.5 million an hour.
Per hour. And that lets them react to supply disruptions incredibly fast. What used to take maybe 2 or 3 days to sort out, they can now address in under 4 hours.
That speed is the difference between a stocked shelf and an empty one during crunch time.
Absolutely. And this reliance on data and models also fuels those emerging techs we touched on, like digital twins. Siemens used them in their Amberg plant, got a 30% boost in flexibility, 20% in productivity.
And it links into things like 3D printing too, right? Additive manufacturing.
Definitely. AI isn't just designing the part, it's optimizing the actual printing process, figuring out the most efficient tool path, monitoring the print quality layer by layer, especially for complex multi-material parts.
Boeing uses this, I believe.
Yes, Boeing has reported seeing assembly time reductions of up to 80% in some areas by combining digital twin simulations with these advanced optimized production methods.
Okay, prediction, perfection, automation, optimization. It sounds incredibly powerful. But we promised a hidden bonus, something about security, because connecting everything like this feels risky, doesn't it? Cyber attacks.
It's a massive concern, and rightly so. Sources show almost half, 48% of manufacturers see cybersecurity as the biggest single threat to these smart factory projects.
You're merging the factory floor equipment, the OT or operational technology with the IT networks. That creates a much bigger attack surface.
Exactly. And the threats are real and dangerous. We all remember Stuxnet, the malware designed specifically to cause physical damage to industrial centrifuges.
Right, it wasn't just about stealing data, it broke things.
And newer threats, like Trident malware, specifically target safety systems in industrial plants. The potential consequences are terrifying, not just financial, but physical harm.
So, here's the good news.
Yeah.
You said there was a counterintuitive solution here.
Yes. It involves something called edge computing. This is where, instead of sending all the sensor data back to a central cloud or server for AI analysis, you process a lot of that data directly on or near the equipment itself at the edge of the network.
Wait, so doing the AI processing locally, not centrally, how does that make it more secure? Wouldn't less centralization be better?
It limits the exposure. By processing critical operational data locally, you drastically reduce how much sensitive information needs to travel across the network to a central point.
Right.
Fewer data streams mean fewer opportunities for interception or broad attacks.
Ah, okay. So if one edge device is compromised, it doesn't automatically compromise the whole system.
Precisely. It contains the potential blast radius. Each edge node handles its own analysis, making the overall system much more resilient to certain kinds of large-scale attacks compared to a purely centralized model. It compartmentalizes the risk.
That's fascinating. So the very technology enabling advanced automation, this distributed edge intelligence, inherently adds a layer of security hardening.
It can, when implemented correctly. It's a key part of the strategy for things like Samsung's planned fully automated chip factories for 2030. Decentralized intelligence helps manage both performance and security risks.
Okay, let's tie this all back together. We've covered a lot of ground. What's the bottom line impact we're seeing from all these AI applications in manufacturing?
Well, financially, it's undeniable. We see overall equipment effectiveness, OEE. That's kind of the gold standard metric for productivity consistently improving by 15 to 25%.
15 to 25% better use of existing assets. That's huge.
And unscheduled downtime. In some sectors, like semiconductor manufacturing, we've seen reductions of up to 72%. For one fab, that meant saving over $4.3 million a year.
So the financial case is clear. But what's the bigger picture here?
The bigger picture is that this isn't just about saving money anymore. It's fundamentally redefining industrial competition. The question isn't if AI will transform your manufacturing operations, it's how quickly you can adapt.
It changes the whole mindset, doesn't it? From reacting to problems to actively preventing them.
Exactly. That ability to predict a failure months out, or to design processes that prevent defects from ever occurring. This shifts leadership focus from managing risk to essentially guaranteeing performance.
We've seen how AI saves billions, boosts quality, connects the factory. But yeah, that core revolution really is prevention. Moving from reaction to foresight. That's the essence of Industry 4.0.
Couldn't have said it better myself.
Okay, that wraps up our deep dive for today. But next time, we're going somewhere maybe a little uncomfortable. We're tackling dark data.
Ooh, intriguing.
Yeah, that's all the information your company collects, stores, and then completely ignores. We're going to show you why that ignorance is costing the global economy trillions and unpack the 3 critical ways AI is finally forcing businesses to confront the data they've kept hidden in the shadows.
Sounds like a must listen.
You really won't want to miss that deep dive. See you next time.